Hello, algebra students. Mr. B again. All right, we're into the second video of graphing, at least the second example, I think it's the third video, of graphing rational functions. This rational function we see is already factored for us. If we wondered what was going on with the standard form, we could just think about multiplying out these factors on the top. If we did that, do you see that the first term would be x cubed? Because the first binomial is squared, so you're going to get an x squared out of that. And then that's going to multiply this x and give x cubed. And then there's going to be a bunch of other terms, but there'll be a 1x cubed out in front. We're going to need that later. In the bottom, the same thing would happen. We're going to get a 1x cubed and some other terms. We'll use that later. All right, so step one was looking for factors that were the same on the top and the bottom, and I don't see any. No common factors. So we won't have to deal with that. You might recall in the last video we had a common factor and we excluded the 0 from that factor from the domain of the function. Anyway, not an issue here. 2, x-intercepts. X-intercepts. Where are they? They're at the zeros of the numerator. Where's the numerator 0? Well, I see immediately that x equal 4 would make the numerator 0, and x equal -3 would do it. Now, the multiplicity is important because that's going to tell us about the behavior near that x-intercept. So the 4 has a multiplicity of 2. What does that mean? That means that the graph is just going to touch the x-axis. So graph just touches the x-axis. And the -3, 0, that has a multiplicity of 1. So the graph goes through the x-axis. Just say graph goes through. Okay. So next, y-intercept. Y-intercept. That's always at x equals 0, so we need the function value at 0. In this case, we don't have these general form, standard form to just look at the last terms. It's a little harder in this one. Let's put 0 in for x everywhere and see what happens. So we'll get like 0 minus 4 squared times the quantity 0 plus 3, and in the bottom the quantity 0 plus 2 squared, and the quantity 0 minus 2. And what's going to happen here? -4 squared, that's 16, times 3. In the bottom, it looks like we're going to get a 4 times a -2, a -2. Let's clean this up a little bit. 4 is going to go into 16 4 times. 2 goes into 4 twice and into itself once. So it looks like we're going to get -6. I see one negative out of everything, so that's going to be negative. So the y-intercept is -6. All right, next. We want the vertical asymptotes, right? I think my numbering system's wrong. Yeah, maybe not. Vertical asymptotes. They're at the zeros of the denominator. So what makes the denominator 0? I see x equal -2 and x equal 2. And the multiplicity is important. The -2, 0 is got a multiplicity of 2. So we know that this, near that vertical asymptote, the graph's going to kind of look like 1 over x squared. We have an even multiplicity. So what does that mean? The graph's going to look like this, or like this, or it could be the negative version. It could be like that, or like that. And we're only really interested in what's going on right near the asymptote. I'll circle that area. We don't care what's going on to the left and right. It's just near the asymptote that's important. Okay, and then the 2, the 0 that is 2, that has a multiplicity of 1. And we know that that looks like 1 over x, or negative 1 over x. So like this, or like this. And again, we're only really interested in right near the vertical asymptote, not off to the sides. Those are clues to help us graph later. Okay, next. What's the horizontal asymptote? Well, I should be spelling it out so you know what I'm saying later. Horizontal asymptote. I'll just abbreviate horizontal asymptote. All right. So what we need to do here is go to these standard form versions of the numerator and denominator and look at the leading terms, and especially look at the power of those leading terms. We need to know the degree of the numerator and the degree of the denominator. In this case, they're the same. Remember, we talked about this, that the top one is n and the bottom power is m. And when they're equal, then the horizontal asymptote is the ratio of the leading coefficients. So first, let's say n equals m equals 3. And that means that the horizontal asymptote, the HA, is y equal, I think we had a sub n over b sub m. Can't even read that. Let's make it better. B sub m. Just means the leading coefficients. Here it was 1 and 1, so it's 1. Y equal 1 is the horizontal asymptote. Here, let's look at that again. You see the 1 here and the 1 here. Those are the leading coefficients. Sometimes they're not 1, and the horizontal asymptote could be somewhere else. It could be negative for all we know. But in this case, it's 1. Okay, now we're ready to graph. Let's get some axes going. And let's see, start with x-intercepts at 4 and negative 3. 1, 2, 3, 4. We'll put a dot there. Negative 3. 1, 2, 3. Y-intercept was negative 6. I'm just going to put a dot down low here. Negative 6. And what's next? Vertical asymptotes at negative 2 and 2. Negative 2 and 2. Okay, let's start thinking about what's going on here. So between the two vertical asymptotes, I always like to start in the middle if I can. I don't see any x-intercepts in there. The only thing I see between those two is the y-intercept. And that means that the graph must go somehow like this. Okay? There's no other way it could go. It's got to get closer to the asymptotes as you get closer to the value of, the x value of those asymptotes. And it's got to go through the y-intercept. So this is it. Okay, let's go to the left branch now. We see that we have an x-intercept there at what, -3? What was the multiplicity for that one? That was 1. So the graph goes through there. Oh, you know what I forgot to draw as well, sorry, is the horizontal asymptote. I should have drawn that earlier before I started drawing the graph. Okay. There's still no, that first little branch I drew is fine. Let's put a 1 there. Okay, so this is important. Now, let's go to the left branch. What does it look like near the vertical asymptote at -2? What was the multiplicity there? It was 2. So it either was on the top with both graph branches next to each other, or at the bottom, like this. They weren't opposites where one's on top and one's on bottom, like the odd multiplicity. When it's even, they're together. They're peeling off the asymptote together, top or bottom. And in this case, we can see it's got to be coming off the bottom, right? Since that's the description based on our thumbnail, right? So it's got to come up and go through the x-intercept, and then it's got to get closer and closer to the horizontal asymptote. Whether it crosses the horizontal asymptote or not, let's save that for later. So 1, 2, -3. I want to get the numbers on there. Okay, how about the other branch? On the right side, I see this x-intercept there at 1, 2, 3, 4. I think the graph just touched there, right? Just touches. And what's the behavior near that asymptote, the vertical asymptote at 2? I think that was odd multiplicity, and so it's got to have sort of the opposite. If it's coming off to the left at the bottom, it's got to come off to the right at the top. And I think that's what we have, right? We don't have like this other one where it's going off to the right. Well, on the left side, it's not coming off from the top to the left. We don't have this. We have this on the bottom. So we have to have this on the top. So let's go do that. It's got to peel off the top like this. And it's got to come down and touch. Whoop, and my guess is it's not going to cross again. It's going to go like that. Let me erase what I just did. It could cross, but it's usually pretty rare. So it comes down off the vertical asymptote from the top, touches at 4, and then bounces back and then gets closer and closer to the horizontal asymptote. What's fun to do is to use like Desmos or GeoGebra online graphing tools and see how close you got after you're done with this. The last step that's kind of good to do, unless you're stretched for time, is to see if the graph crosses the horizontal asymptote anywhere. And the way you do that is you set the function equal to the horizontal asymptote. So this is sort of icing on the cake. I probably should have given us the standard form for the top and bottom. X minus 4 squared plus 3. Sorry, x plus 3. I'm just trying to reproduce what the r of x was. And the denominator was x plus 2 and x minus 2. That was squared x minus 2. Actually, I have it here. Hang on a second. Let's see what I had. Oh, I didn't multiply it out. Didn't multiply it out. Okay, I'm going to pause and I'm going to figure this out. All right, folks, I have multiplied this out. I didn't want you to have to wait while I did all that stuff. I just paused it. All right, so what we get is x cubed minus 5x squared minus 8x plus 48. And on the bottom, we get x cubed plus 2x squared minus 4x minus 8. Minus 8. All right. And we're supposed to find the solution of that equation, well, set to 1. Sorry. What am I doing here? You set it equal to the horizontal asymptote value. Where is this equal to 1? Where is the rational function equal to 1? It would, like if this crossed somewhere, well, we know it crosses here. That's going to be one solution right there. Okay, so let's solve this. It may look a little gnarly, but we know how to solve rational equations. We multiply both sides by the LCD, which is this denominator, and the right side is 1, so it's really easy to see that we're just going to get x cubed minus 5x squared minus 8x plus 48 equals x cubed plus 2x squared minus 4x minus 8. Immediately you can see if you subtract x cubed from both sides, that goes away. And now I'm starting to see a quadratic sitting here. So I'm going to add 5x squared, add 8x, and subtract 48 from both sides. 5x squared, 8x, minus 48. And what do we get? We get 0 equals 7x squared plus 4x minus 56. Okay, so let's see if that has real solutions. We'll use the quadratic formula, right? So I get negative 4 plus or minus the square root of b squared, which is 4 squared, minus 4ac. A is 7, c is negative 56, and then we divide by 2a, 2 times 7. And I'll just put this in a calculator. And what I got was approximately negative 3.1 and 2.5. Hey, that kind of fits with what we have, right? 2.5, sort of. About 2.5. It's not exactly 2.5, but close. And then over here at negative 3.1, we know that the graph really came up and crossed and then got closer and closer to the horizontal asymptote. And this value where it would touch is about 3.1. Let me erase this so we don't have to look at it. There we go. So this point right here is at x equal approximately negative 3.1. All right, that's it. Sorry for the long video, but there were a lot of details here. This was fun, right? All right, we'll see you in the next video.